sharing.
Okay, it looks like we are starting our next session. So today is Tuesday, 12th of April. We are in Colombo. And yes, Sri Lanka is a perfect place to do information technology. As far as I know, it's probably among the fast growing communities in the world. The most it's really developing well. So welcome everyone here. Okay, and today, as we promised, we'll have a questions and answers session for the lecture number 2, which was on decentralized finance, right? So now you should see my screen. So the course is our course is on verification of smart contracts on the Ethereum blockchain. We already had 2 lectures, more or less introductory. The first one was about general ideas of formal verification, of formal proofs of axiomatic approach to analysis of domains. And second lecture was kind of basic introduction into blockchain technology, into Ethereum, Solidity. And today, okay, the plan is quite similar to what we had yesterday. First, I will start with questions related to the theory, to my slides. Then we'll go through the test I suggested you after the lecture for self-assessment, and maybe you're interested in getting certificate from Exactpro or maybe some future work in this area. Then I definitely suggest you to do homework, and test was first part of the homework, and the second part was a task on Solidity. I will also discuss this, although I will not show you the exact solution for this task, but we'll speak about coding Solidity. So first about theory, and on Friday during my lecture, I started with basic definition of blockchain, and you probably remember this slide. That basically the idea that instead of having kind of a trusted, dedicated party who will keep track of all our transactions, like who gives which amount of money, the idea of blockchain is to keep this information on every node, so everyone has the history of all transactions. And the one question I probably missed is why this technology is called blockchain. So this is the answer, because as I mentioned, so technically blockchain is append-only ledger. So it's a database which is not intended to delete anything. So you only add information, because in finance it's really important to know the whole history. So you just add new information from time to time. That's why the structure of this database is looks like this. So it's just sequence of different blocks, like block number 1, block number 2, etc., etc. And each of the blocks had some header, which this proof of work, which we already discussed, and some information connection to the previous block. And then the body of every block is actually the list of transactions. So we have some sequence of transactions, then a kind of we come to some consensus that okay, these transactions are really done. We put them into a block, then someone, really the miner, signs it, and then we go ahead. So at the end, if you just look into your database, it consists of the sequence of the blocks. That's why it's called blockchain. So chain of blocks, which is called blockchain. So basically the idea, yes. And if you go ahead with this idea so that was the initial idea of Bitcoin. But if you're speaking about Ethereum platform and about smart contracts, then in addition to the transactions, to the information about transfers of money, each block also contains some smart contracts, which I assigned to different nodes. So this basically justifies the name for blockchain. Okay, that was the first question. And the second question, that's probably another big topic, why mining? So I tried maybe to explain a little bit, but maybe not enough. So the main reason for mining the decentralized consensus in no trust environment is really a difficult issue. So just imagine some perfect situation. I mean, perfect, which is like idealistic. For assume you have like 10 people, and everyone like is a perfect person in terms that no one lies. Everyone try to do the best for the others. But even in this situation, if these 10 people have some idea, for example, how to invest money, that's really difficult to come to some consensus, because some people may like this idea, other people might love different idea. Then okay, they maybe some groups are formed, then some discussion. It might happen one group, the other group, and this is quite a well studied situation. It may happen that sometimes that even the smallest group may have kind of the biggest influence. For example, one group is of 4 people, another group has 4 people, and then you have another group of 2 people, and then these 2 groups, 4 and 4, kind of can disagree on the solution. Then, but all of them kind of agree that the majority will decide. So finally, you come to the third group, which consists only of 2 people, and then these guys really decide whom to join. So you see, even in perfect situation, when you have no kind of no bad guys, no criminals, no one tries to hack the system. Like you believe that everyone is kind of doing trying the best. But even in this perfect situation, to reach consensus is a difficult task. But in real life, it's even more difficult, because definitely some people will be not some participants of the system will be not that good. Some will try to hack the system. Some will try to steal the money from others, etc. And then you need to design an algorithm which will always work in this imperfect environment. So the idea of this proof of work is actually quite smart solution. It was suggested in the original paper by Satoshi Nakamoto, which introduced Bitcoin, and that's just spend maybe some time just to read it and to understand the basic idea. But basically, although this idea of decentralized ledger is quite simple, technical implementation, which will work in this imperfect environment, is quite tricky. Yes, and another point I'd like to mention today is that surely there are different approaches to this consensus mechanism. So the most kind of used today is proof of work, but it needs high energy consumption and a lot of processing time. So, for example, if you don't have like a huge not even one, maybe several computers, don't even try to participate in this system, because currently it really takes a lot of energy and a lot of processing power, etc. So this is not good, because actually these people just doing some silly stuff, actually running some random combinatorics just to prove that they are to find the consensus. So there are already some other ideas how to reach consensus. The second is proof of stake, and here is the idea is the allocate responsibility according to the number of virtual currency. So it's similar to in the first algorithm, proof of work, your random generator find kind of the guy who will be the next to sign the transactions proportionally to the computing power. And in this approach, it will be in proportion to the number of virtual currencies. The guys who have bigger savings will be more likely to sign the next transactions. And in this case, you don't need to run your processor to compute to solve some problems, so some tasks. And this is a much more promising approach. And another example of a consensus algorithm is based on proof of capacity. The idea again similar that you do it according to hard space, for example, and the more rights is granted for according to the guys who provided the system with bigger disk space. But again, all these are just mathematical engineering solutions to the problem of decentralized consensus. That's basically the comment. Yes, and if you have another questions, comments, just feel free to ask, and I'll try to continue maybe this or another topic in other lectures. Okay. Another question about my slide was about initial coin offering, and the question was about, there are kind of two similar stories. First, I tell you about Bitcoin, about Ethereum, how it's really organized, about all this idea of mining and consensus algorithm, and this complete complex infrastructure. And then I tell you that, okay, everyone can issue his or her own currency, and people quite often miss the idea. So in order to issue your own currency, your own crypto tokens, you don't need to design the whole system from the scratch. So you can, most of new crypto projects, they already use the infrastructure of Ethereum or similar platforms. So everything you need is already done. So you don't need to design the algorithm of consensus. You don't need to motivate the participants. You just go to Ethereum and you create your own table, which will be saved to the Ethereum database. So, and this your table is exactly the ledger for your new currency, period. So basically the idea is that it's like creating a new business. For example, you would like to build a new factory, and in some new land, you found some a new island or whatever, and then definitely first to think about the power plant, then about the roads, about the buildings, about all the infrastructure, and that will be quite difficult and expensive. But once you come to already well-developed territory, you don't care about where to get electricity and where your employees will live, because typically it's already a town or city or whatever, which already has some power station, which already has some hotels or apartments, and you only think about your business model. So similarly here, Ethereum already provides you with all the infrastructure, so you don't have to care about how to motivate miners or whatever. So you just think about your business model, then you create smart contract, you put it onto Ethereum platform, and then your business starts. That's the idea. So to create new cryptocurrency, you don't have to care about mining and infrastructure. You just use Ethereum or other platform. That's my next comment. I hope now it's more clear. Okay, let's go ahead. Yes, the other question was related to decentralized autonomous organizations, and yes, this is quite interesting topic, and many people like believe that our future will be not in democracy or other political situation, but in algocracy. That algorithm will run all the all the governments, because algorithms are just could be perfect, hopefully, because people are never perfect, but algorithm could be. Some people believe, but that's exactly the comment I would like to put here, that decentralized autonomous organizations do have some issues. So they are not perfect yet. And the first issue of DAO is security. And okay, this is just to think about that, because every code is open, and there is kind of a law among software engineers that every piece of software always has some bugs. So it's almost impossible to write a code without bugs. And if this piece of software runs your organization, then this bug could be very dangerous. And the first issue is security. The second problem of decentralized organization is reduced speed of decision making. So, like in the example I mentioned in the beginning, it seems we have like 10 people who need to decide how to invest their joint money. Then the algorithm could be perfect in principle. I mean, the algorithm which implements the decision procedure. But anyway, they need to discuss all possible opportunities, all pro and contras. And since they are kind of equal, they don't have the manager who at some point will just say, okay, we'll do this and that. Let's stop discussion. It might take quite long time. And you see bullet number 3, it's sounds quite funny, but it's quite real that it happens that trivial matters are discussed extensively, while important matters are unattended, because each of us has a very limited resource of time. And if you come to some discussion in your organization, typically people start from some simple issues, but at some point your time is gone, and serious and important matters are not discussed at all. So decentralized autonomous organizations is really a nice, promising idea, but I should really add this comment that there are still some issues and the future is not that clear. Okay, and the next question. Yes, our section was the last section in lecture was about Solidity. Yes, which is a high-level programming language specifically designed for Ethereum. And the question was about whether there are another programming languages. And here just a short summary. I just collected from the web about different languages which are used for blockchain systems, and you see probably some familiar names, and many people agree that C++ is still number one, because for blockchain technology, the performance issues are really on the top currently, and C++ is really rapid and powerful, and it's on the market for tens of years. And but on the other hand, it's quite complex language, and complexity increases with the length of coding. So to build a huge project in C++ requires really professional team. The other choice is Java, which is well known and which is developer friendly, but it's slower in performance if you compare to C++. Another choice is Python. It's also very widely used because, again, because of its extensive open source libraries. And JavaScript. JavaScript is very popular now for different reasons. First of all, because you always have web interface to almost every application, and blockchain is also the case. So you will need JavaScript to build front end for your system. But also JavaScript is very good at handling asynchronous actions, which is very which is at the core of all this financial system. When you have like numerous people in parallel asynchronously sending money to each other, and it happened that JavaScript is really very good for working with that kind of systems. And other languages like Arabic, Golang, C#, etc., are also well used. So it's usually you have a lot of different options. Some options are better in some sense, some are better in the other sense, and it's up to you to make this design decisions. And okay. And in addition to this kind of general purpose programming languages, there are also many new projects of programming languages designed specifically for coding smart contracts. So there's another big field, and surely Solidity is not the only choice. Okay, then we also spent some time on Ethereum virtual machine, which is actually the runtime environment for smart contracts. And the question which I got is where actually this virtual machine physically runs. Because again, once you have algorithm, you code it, then you compile it, then you need to deploy it somewhere. And okay, since Ethereum is decentralized, you cannot have some designed kind of server room or some cloud instance to run your code. So the answer is rather straightforward, that every Ethereum node runs every contract just to maintain consensus, because there is no other way to ensure consensus. So each node needs to rerun all the computations itself to check that indeed this transaction happened. So that's the answer. And another comment that again, think about this database, which is sequence of blocks, chain of blocks. So basically, the idea of this virtual machine is just to compute next valid state of this database. So from block to block. So basically, the idea of Ethereum virtual machine is to collect all inputs, compute all contracts, and then get to the next block, which will be stored into the Ethereum blockchain forever. Okay, that was regarding the theory. Yes, thank you for comment. It's also important property of the smart contracts that once you create them, there is no way to alter them, effectively acting as an unbreakable contract among participants. Yes, thank you. And again, this is good. If you're speaking about decentralized autonomous organizations, it is, this paradigm that code is law. So you have this law, everyone sees this law, and everyone works according to this law. But on the other hand, if at some point you realize that there is a bug, that there is some incompleteness in this law, it's extremely difficult to change. So you'll need kind of the 100%, okay, almost 100% consensus just to agree that okay, we'll shift from this version of contract to another one. Okay, thank you for comment. And let's switch to the test. Okay, let me open it, Google Forms. So, okay, okay, let me make it larger. Now it should be better. So the first question, which of the following is not a distributed application? Okay, Facebook. So one has to recall the idea of a distributed application is an application which runs on different nodes, right? And Facebook definitely runs on different computers because you have client on your phone, on your desktop, you have some servers on the backend. So definitely Facebook is a distributed application. Again, Zoom. Zoom is communication software. So similarly, you have someone calling, someone receiving calls. So you have like the conference, etc. So different computers, different processors are involved into this application. So it's definitely distributed. Google Maps is not that clear, but again, it's definitely distributed because you have at least two nodes on the two computers on the web. The one which is responsible for backend. You need a server which keeps all these maps and works out all the requests, and then you need client which is on your phone, on your desktop, on your other device. So again, Google Maps is another example of distributed application. Okay, and Adobe Photoshop. Okay, just by exclusion, that must be correct answer, but I assume it's quite clear that this is not a distribute because you can download it on your computer and then just turn off the internet, and without Wi-Fi it still will work. So it does not need any other computer to work. So Adobe Photoshop is not a distributed application. Okay. Question number 2. What is distributed ledger? First answer, first option. A database that is synchronized and accessible across different sites and geographies by multiple participants. Okay, that sounds more or less correct, but you see, this option says nothing about content of this database. So it might happen that this database keeps like your pictures or video or some other information which is not really a ledger. So first option is more or less close, but I assume it's not correct. Second, a software package designed to define, manipulate, retrieve, and manage data in database. That's more like a database management system, not a ledger. Okay, option 3. An application comprised of multiple clients that communicate with servers or machines through a network. Looks like general definition of distributed system. A statement. Distributed statement that presents the financial status of a company at a certain point in time or over a stated time period. This looks like the most, or the first one. Okay, among the three, the first one is surely the most close to the question, right? Because, right, it's not the second, it's not the third, and yes, financial status is not really a ledger. It's more like report. Okay, number 1. So why do Bitcoins need to be mined? Okay, to make the service continuous and always available for horizontal scaling of the system, for detecting. So second, definitely no, because mining doesn't really scale the system. For detecting quarantine and detecting malicious code looks like antivirus, because they are entirely digital records and there's risk of copying, counterfeiting, or double spending the same coin more than once. So it's either 1, either 4, make the service continuous and always available. In order to make it continuous, you just need to turn on your computer and you don't need this tricky mining algorithm. But the mining algorithm is really necessary for consensus, which is exactly because of risk of copying and double spending. Okay, so clearly number 4. Okay, so what is smart contract? And the first option is a short, straightforward document that serves as the foundation for a project. No, it's not. It's not. A set of well-defined instructions to solve a particular. That sounds more or less, but okay, what's the particular problem? I'm not sure. Let's read the third one. A legal contract for the purchase or set from buyer for seller. It says nothing about algorithm. An agreement between two or more people in the form. Yes, this looks okay. An agreement between two or more people in the form of computer code. And this one, a set of well-defined instructions to solve. You see, the second option does not require it to be written as a piece of code, but smart contract is a piece of code. So here we have number 4. Okay, who can launch an ICO to raise money by selling tokens? Okay, any passport holder. Okay, 21 years old. Anyone qualified cryptocurrency broker. Now, in future, probably you'll have something like that. But currently, this is completely not regulated field. So currently, like anyone can do that with actually almost no restrictions. So the right answer is 4. Which of the following is a non-fungible token? Okay, let's recall. Fungible it means if they are kind of the same, like $20 bills is the same as 10 plus 10. But non-fungible if each of them is unique. And Bitcoins are kind of all the same. US dollar from practical point of view are all the same. Gold, again, from practical point of view, you can consider the same. So only amount matters. But event tickets are everyone is unique because you have specific date, specific row, specific seat, etc., etc. So definitely event tickets are non-fungible tokens. Okay, what is agocracy? It's a government in which the highest power is used through representatives. Looks like democracy, but nothing about algorithms. Okay, let's keep this in mind. Second, a rule that is used to order the way in which a society behaves. Again, looks like more general law system. A globally connected network system facilitating worldwide communication. This is probably a definition of internet in general. A system of government based on the usage of computer. This is definitely the correct answer because again, the others mentioned doesn't. Okay, this is not related to computers, just general approaches, and this is about algorithm, but it's just about connected systems and communication. But algography is more about government, not communication. So yes, number 4 is correct. And then the last question was right is implementation task. So you have two guys who need to exchange, for example, one currency for another. So I have like Bob has dollars and needs pounds, and Alice has pounds and needs dollars. Then instead of using some third party, they use smart contract. So Alice sends information. Okay, I am, for example, okay to sell my pounds with this amount with this rate, exchange rate, and Bob says, okay, I'm okay to exchange my dollars for pounds for with this exchange rate and this amount. Then contract automatically checks the suggested exchange rates and computes kind of the perfect one, which will be okay for Bob and Alice if it exists, and then makes this exchange, or says that guys you cannot agree because your rates are not yeah, you cannot kind of agree on something which everyone will be happy. So I will not show you the solution today because we still have some time for you but let me show you a similar task. So here, right, there is a very nice online platform which called Remix. It's located on Ethereum.org portal. So here is my my piece of code. Okay, yes, and I just implemented very simple just store data class contract. So okay, let me go step by step. So you first you create your file here, right? I called it test. .sol is quite a clear extension for Solidity files. So we start from just some comments and then define this class, which has one variable which is called store data, and then three functions. Let's set this value, get this value, and auxiliary function compute. Then we go here to compiler. We choose the version, language. What I mentioned, you see there are even other options besides Solidity. And then, okay, let us introduce some bug. For example, I forgot here something. Compile. You immediately get here like error message, which helps you to fix everything. Okay, let's compile again. So you see this green symbol to indicate that compilation is successful. Then you go to the next step and you can deploy your contract on, surely it's kind of a test environment. It's not real Ethereum, because otherwise you may lose all your money by running some imperfect code. So it's a test environment, so everything is safe. There are some options. Okay, you just take the default one and you push deploy button. So again, you see everything works. And so once it's deployed, here you see you get button for every method you have in your contract. So in our case, we have set, which in this one, compute, this one, and get. And you see the set is orange one and is different color because it changes the state of your database. So this value will get different, will be updated. So this method will transact something, and the other compute and get, this get is just to read the information, compute is just to compute some function. Okay, let's do something. For example, we have something like 2, 3, doesn't matter the meaning, so it's somehow compute, and then you can get the value, it's 6. Probably it's some kind of exchange, or you buy something, like you have some, okay, 7, 4, and here you get like 28, and just maybe to get some hint for our next lecture, let's try to think a little bit about this example. For example, you create your own tokens, your own currency, and initially you kind of believe that you will have very small amount of these tokens, like for example not more than 100, and so you use this short int variable which is always less than 255. So you define this variable, and you're kind of happy to be sure that okay, it will be always, because again, you assume that stored data will be always small. Then you build this compute function, then set, get, etc. But at some point, you will have the situation when some integer are kind of long integer and some other are short ones. And this is the most typical situation when you can get this arithmetic bug. So at some point, okay, one developer decided, okay, here, let me write, for example, this way. Let me remove this one. For example, you see, this is just a trivial compute function, right? So you get two parameters, x and y, and you return x times y. Simple. But if you try to compile this, you will probably get an error message. And indeed, because here on the left, you have short integer, and on the right, you have kind of n init integer which could be long. So professional software developer will probably think about the situation and suggest some serious solution, but it may happen that you have a junior developer who just will write something like this. Okay, let's write something just exact transformation here. Okay, then compiler is happy, right? Why not? Sorry, I forgot you. Okay. So compiler is happy. We fix the problem, and then okay, we go ahead, and some other guy just tests this. For example, let's write 2 4. Then compute it will be 8. Okay, it's 7 4. It will be 28. But then you write 740. Each value is less than 100, rather small. You transact, you get, and you see the result is 24. And looks like a bug because, okay, I don't have much time to discuss the reason for this bug, because, okay, some guys would expect that this is real multiplication. Some other probably have written in some inside the specification that this is not real multiplication, but something else. But this is the typical situation when you have some incompleteness of documentation. That's why people might treat your contract in different ways. And someone would expect this behavior, some other different, but surely not everyone would expect that if you multiply 7 by 40 would result in 24. And that may kind of result in some vulnerability or some serious system crash or whatever. And this is exactly an example when you need to add some constraints, to add some preconditions, post conditions, and preferably not just test, but formally prove that the post condition, the preconditions, that invariant are really valid for all possible input and output values. That's why we need this verification technique. Okay, let's return back to our slides. So, right. And this is the last slide. So, but just remember that the whole idea of this Solidity code is just to write another piece of transactions into your blockchain database. That's it. So in general, the functionality of every smart contract is very simple, very straightforward. Just change the state, change the ledger of your database, and then just submit it to the next block. period. Okay, thank you again for comments and questions. Yes, nice example of a bug. Yes, it's a well-known loss which resulted in loss of $50 million. Yes, so it's quite serious amount, and it would be okay maybe to spend some part of it on formal verification than to lose everything. Okay, thank you again. So we'll continue on next Monday with lecture 3 on, it will be our final lecture, and I will speak about real examples of formal verification of Solidity contracts. So, okay, thank you, and questions, comments are welcome. Let me see. No more questions, no more comments. Okay, thank you. Goodbye.